Mastering Square Roots and Cube Roots. Welcome to an exciting journey in understanding square and cube roots, essential components of mathematics that unlock many secrets. Imagine the thrill of knowing how to find the hidden dimensions of a simple square tile. Let's dive in and uncover these mathematical mysteries. Remember the square tile with an area of 50 square centimeters. How do we find the side length when the number isn't perfect? Approximating square roots or cube roots can bridge that gap, turning complexity into simplicity through practical methods. In the previous lesson, you learned that the measure of one side of the square is the square root of the area. In this case, the measure of the side is square root of 50. However, 50 is not a perfect square. How would you solve that? Square roots are tied to the area of squares, while cube roots relate to their volume. Though seemingly different, finding them can be intertwined in the beauty of mathematical logic. Explore how closely these roots connect, serving as keys to unlock new layers of understanding. Numbers fall into two families, rational and irrational. Rational numbers fit neatly into fractions. These are numbers that can be written in the form a over b, where a and b are integers and b is not equal to 0. Example, the number square root of 4 is a rational number since square root of 4 is equal to 2. On the other hand, irrational numbers are the opposite of rational numbers. Irrational numbers defy such neat expression, intriguing us with their non-terminating, non-repeating form. Discover these families and see where roots intertwine within them. Example, the number square root of 3 is an irrational number since it cannot be expressed as a fraction consisting two integers. Approximation methods like Heron's method for square roots or linear approximation for cube roots provide handy tools. These approaches allow precise estimations that lead to enhanced problem-solving abilities. Equip yourself with these techniques to tackle real-world mathematical challenges. These are the steps in approximating square root. Let's learn these steps slowly. Example, approximate the value of square root of 18. To approximate square roots, we can use Heron's method. The steps in performing Heron's method are as follows. Step 1 is take a first guess. We can start our first guess by determining the square root of the closest perfect square that is less than 18. In this case, this number is 16, and its square root is 4. Thus, our first guess is 4. Step 2, divide the original number by the guess. First, we divide the original number by the first guess. 18 divided by 4 is approximately equals to 4.5. Step 3 is to add the guess to the quotient in step 2, and that is 4 plus 4.5 is equal to 8.5. The step 4 is the last step, which is to divide the sum by 2. Now remember that in the step 4, the 2 is always constant no matter the value. Hence we have 8.5 divided by 2 is equal to 4.25. This means that the square root of 18 is approximately 4.25. While Heron's method is useful in square roots, it cannot approximate the value of cube roots. Hence, we use linear approximation that uses calculus to solve the value of cube root of a number. Here are the steps. Let's dig further. Try to find the value of cube root of 10. Step 1 is to determine the two perfect cubes closest to the given number. The two perfect cubes that is closest to 10 is 8 and 27. The biggest is 27 and smaller is 8. Step 2 is to subtract the smaller perfect cube from the original number, that is 10 minus 8 is equal to 2. Step 3 is to subtract the two perfect cubes, that is 27 minus 8 is equal to 19. In step 4, we need to divide the value we obtained from step 2 by the value in step 3, that is 2 divided by 19 is equals to 0.105. Note that in step 4, the arrangement must be correct. 19 divided by 2 is equal to 9.5, which is incorrect, so be careful. Also in step 4, the answer is always in decimal. The last step, step 5, in step 5, we add the value from the cube root of the smaller perfect cube, that is cube root of 8 is equal to 2, then we add the result from step 4, that is 2 plus 0.105 is equals to 2.105. This means that the cube root of 10 is approximately 2.105. Note that the approximation will give us answer that is closest to the correct answer, but not the right answer. I hope you learn from this video and apply it to our daily lives. Remember this quote, "The only way to learn mathematics is to do mathematics." Thank you and God bless.